Yeah, that's
I
okay.
have the 2 recordings from last night. Should I post it in Slack? In our group chat?
Did we say anything offensive? I don't remember. Up to you.
I mean, if you guys want it, I'm
Post it.
Okay.
Anyway, so once you have this, so again, Danny's found out a couple other things that I would love to get more information on, and he's still investigating, which is, you have other extension pieces out of the this that you can do, like watches and ohms, and then that gives you more things that you can watch, and then he also figured out that there are ways to do a controller set, the setup controller such that you would be able to. It's better to look at its code actually.
An ohm is basically, it's Wim here. Yeah,
Wim is here too. Amazing.
Oh,
I didn't even know.
Yeah, I joined late. I didn't pay attention. But yeah, an own is basically its owner reference. So if you create an object so there is 2 things you have to do there. You have to set the owner reference to that object. And then every time there is a change to that object, when you put that own in that part of the code that Steven
so there are 2 differences, right? So ohms,
this one here,
ohms give you another things to watch, but then it's watching not the entire deployment, not all the deployments, but deployments that you tell them that you care about. So
yes.
So in here you set controller reference. The controller reference is the other thing. The controller reference means that the controller reference here means that if you deleted this master object, this is one of the child objects that needs to be deleted also. Yeah.
Can you enlarge this window? It's hard to read. Sorry. Yeah, perfect.
It's already more advanced scenario, right? So what this actually sets a reference to the child object that you create, which is deployment, right? So you create a deployment, and what you actually do with that statement is to say the owner of that deployment is actually me. Okay.
Okay.
And then when you do the own a bit lower on 551, I think, or 552.
Yeah.
Then you get information. So by putting that, so the first thing, the set controller reference, what it does, it says, hey, you belong to me. So now if you would delete the UPF deployment object, Kubernetes has a garbage collector that says, hey, this controller or this UPF deployment disappeared. So I will also delete the deployment. So that's what the set, so 536 does. Okay, so it binds. So it kind of creates a parent-child relationship. So every child object or resource that you create, which is a deployment in this case, you basically say, I am the owner of it. And if the owner disappears, Kubernetes by itself deletes the child object, in this case, the deployment.
Yeah, so this ohms deployment, watches also deployment. The reason why Dennis did that was one of his test case is that he was changing a particular field in the deployment to try to see whether or not we'll be able to to actually still delete it after the finalizers, and it didn't see the effect. Turns out because we don't watch a deployment that belongs to UPF, this particular UPF deployment. So that's why he add that.
Which is
I think the benefits of doing that, because it allows you to know if someone changes a built-in Kubernetes object that the controller created, but then people can still have freedom of changing. Then you can reconcile against that too. But it's a little bit too early to say that.
You're owning these objects that you create, right? So what so statement 536 does, right, is saying you belong to me, right? So that's mainly to have a garbage collector kick in. 552 basically says, hey, I want any update on that object, you have to inform me. So you trigger a reconciliation loop by doing that. So if there is a change in deployment, your reconciliation loop re-triggers. You still have to fetch deployment, but you basically get a trigger.
So the benefits of 4 is that your reconciliation loop is passed with that request that embeds the object that SRE can create, get changed. But then if you ohms, it only means that you care about the associations. Your reconcile loop gets a method get triggered, but then you go fetch that deployment that you care about. That may be one of the things that get changed, basically, right? So something like this happened. But anyway, so go back to the basic. Your reconcile. So for Vishal and Ronak, when you do AMF, here, your AMF deployments get created. So that's the initial case. It gets created. Then if you look into how UPF does it, the first thing it does is to take a lot of other things that needs to be done for other reasons, but then you can ignore it for now. What it does is it creates config map, and then from the config map it creates a deployment. So for you guys' case, the first thing to do would be create a config map and creates the service, yeah, and then creates a deployment.
I don't think SMF. What about SMF?
SMF's the same thing, actually. SMF and AMF are strikingly similar.
Okay.
Yeah.
So that's why my view.
So if 4 of you guys are working together as like a single group in sync up, it would help each other a lot, because it's basically
see, ideally what we should do here is that actually what you see is that there's a lot of code that you will duplicate for SMF, AMF, and UPF. So you should actually build a library that you call, and then you do the specifics of SMF and AMF and UPF in your controller, but the rest is boilerplate or is kind of code that you reuse amongst them. But that's the second step. So first we have to get it to work, and then we have to optimize.
Yeah, I'm laughing because you and libraries when.
Yes, I am associated. See, but okay. I learned it the hard way, Alan, right? So when you start developing this, you see that, okay, I have code reuse, and then you find a bug, and you have to update it 5 times, and it's hard, right?
No, I get it. I'm laughing also because, at least speaking for myself, this is the second operator I'm writing. So,
right.
Yeah, still
learning.
No,
you have to get it. You first have to find the pattern, and once you know that, then it's a journey, in my view.
So running through the config map, which is the tougher one than deployment, although deployment is much larger to build. If you go into config map, the AMF deployment schema that I just gave you guys, which is very simple, would not cover many of the stuff. It has enough information for you to build the SBI. You can do that, except we don't have TLS for now. It has this.
No, UPF is having the SPA, right? The same, we can just copy.
No, UPF doesn't have SBI, so UPF doesn't have this. But then your SBI schema, well, at least I model it after sort of like this, so it should be pretty trivial, pretty intuitive anyway to add it. There's also an NRF AP there here. This only works if they run in the same cluster, or if you have a DNS entry. So you probably have to have an IP address to put in an NRF, but then that's in the future again. And then so now all the other things that you wouldn't be able to do with my simple AMF deployment will come from something else. And then initially, so for you guys to start doing this, hard code it first, and then but make a note of things that you still need beyond the AMF deployment. So and then we can then talk about whether we want them as part of the AMF deployment, or do we want them to be an extension, or like PRMN's case, if it already exists somewhere else, that we just have to add that into the package when it gets pushed, and then inside your controller you have to go read that object, because we kind of guarantee that when we push the package, that resource will exist. But then you have to somehow be able to get that resource. But for instance, all these are configurable parameters. These are things that need to come in from user or some other means, from configuration management. for management cluster. But it's not part of AMF deployment at this point, because if we put it on all of them, it will be a replicated data, because PNOMM is actually needed by SMF and AMF. So in that case, it will come from somewhere. Vim stuff will actually be smart enough to give it to you. Once we know what it is, your controller would have to go read it and then fill that out as part of the config map. But for now, hard code this, but make a note that you need this information somehow, and then we'll go figure out where to get that. So all of this, for example, are not all of them.
It will come as part of AMF deployment as of now.
So how the workflow will work is we don't just push you a AMF deployment. We'll push you a whole package of resources. Your controller watches only the AMF deployment. From the AMF deployment, we will also kind of guarantee that by the time you wake up from the reconcile loop, your namespace will also have all the your namespace. Let's say for now, your namespace would also contain informations on all the other things you need. But then it may not be part of AMF deployment. So there are other resources that you have to read it from. But then for you guys to do the first step though, just watch for AMF deployment, hard code all of this for now, and then make a note of it, and then come back to talk about. We'll come back and talk about how we're supposed to get those informations, because I think right now PLMN would be part of the free2pp package or resource. So you'll be getting that also when you get pushed. The slicing information, I'm not actually even sure we will be configuring that anywhere at this point.
This is the day one config, right? I mean, PLMN and the NSSAI.
Yeah, so people usually only configure that once. And then for everyone who needs it, we'll replicate that onto the package and push it down for every single instance of network functions. Same thing here for DNN. This is already something that is configured by the user. It will be pushed to you. So now we have to kind of figure out what all this other thing is. Network name, I don't know how they're used. But it seems like something that we need to configure outside. And none of this seems to really matter that much because you're not supporting anything other than IE. Yeah, as I said, these things for now, let's just hard code it. And then we'll see whether or not we want to be able to configure them by users. Make a note of it though. So we'll know there are a set of things that you need for config map. And then we'll see whether or not for our one, some of them we may just let it be hard coded, a default value, and then we'll not configure it. And then moving forward, we may extend either 3.5GC or AMF deployment because it depends on whether or not this is actually needed by other vendors or other projects AMFs. Actually, you guys are not really that bad. So we kind of know most of the values will come from somewhere else. And you have your SBI, so you can fill out this guy. And you don't even have to configure the N2 IP on configurations. On the service, you can forget about the labels. You don't need the same label. You can label whatever you want, by the way. So I kind of suggest go ahead and label NF, a little easier for us to know that this is for an AMF. This also comes from the SBI, or you can deduce that because the XGP must be TCP. That I didn't give you, but it should be pretty simple. And then yeah, that's basically it. So the service is an exposed IP address, is an exposed service to the outside, if someone else wants to access it. So AMF and UPF, for example, AMF and SMF, for example, talk to each other through N11. And then for 3.5GCs, that N11 sits on the service bus. So in your case, if actually it's more AMF accessing SMF in this case. If AMF wants to access a particular SMF, they will use the SMF service that we've exposed. And then if they want to reply back, or actually for whatever reasons send something to AMF, they would also access AMF using the AMF service exposures. For ours, in terms of topology, is slightly more complicated than whatever Orange did, mainly because we can just use cluster IP. The AMF and SMF are expected to run on different clusters, but then again, so we'll figure that out later. So for now, the networking is not something we have to tackle for what you guys are doing. So take the SPI part and basically build out this service, and you can create a service. So the two things first thing, create config map, and then create the AMF service, and then the last thing would be creating the AMF deployment. So for the deployment, from what you can see, the first thing you need is the annotations for NAD, for NAD, for NAD. That looks almost exactly the same as what I did for UPF, except it's a lot simpler, as I told on yesterday, because...
By the way, Steven, there is one thing that is important here as well, right? If we, for the POC, if I may, is that if we connect to the service bus, we are saying not multis, or
so those are not multis. So we don't need a multis for the N11s. The AMF, UPF, the SMF, AMF.
Yeah, but that means also that I don't allocate it, right? Because
no, you don't, and you don't have to. So we allocate. So what we'll do probably for the test infrastructure is that we'll use service and load balancer, and then the load balancer will use metal LB. So we sort of talked to Victor about that a little bit already. The metal LB getting the service IP address would have to come from your container lab.
Yeah, but it doesn't work, right? Because so that's the problem with this whole thing, right? Is that so the kind cluster connects to Docker Bridge, right? So then we have no control of what IPs you're going to get. It's actually done there. So you can also, if you want to route between, you have to do it yourself. Container Lab cannot interfere because you're so Container Lab works for all secondary IPs.
Oh, okay.
So so this is also what you saw in Orange demo, right? Is they use Docker Bridge, but they get all these IP challenges. Why? Because they don't control them. It's Docker, and it's so it's all handled internally. So we have no control of what's going to happen there. So my view is that
so if we have two kind nodes and each of the nodes is one cluster, how do we route between them? We don't have control over the IP addresses then. So we don't.
That's the problem, right? So if you put everything to secondary IPs for now, you don't have this issue. Then we have 100% control.
So for AMF and the auto crap, that's fine. SMF and AMF are the only thing that kind of matters a lot, because AMF and SMF are running on two different clusters on our topology. Yeah,
correct. So if we connect everything to secondary IPs for now, right, all of it will work. If you don't, you have to have a lot of stuff to figure out.
Okay.
So that's my view for the POC, for the R1. Let's connect everything to secondary IPs. Everything will work. If you don't, you have a lot of challenges.
Okay.
That's my recommendation, because you don't control the IP. So if we have to route between clusters and stuff like that, someone has to configure it, and it's all happening. So it's like Docker Bridge. You have to ISO.
Okay.
That's what you saw with the Orange POC, right? Is they did that, and now, okay, yeah, of course, the IPAM will not give you the right IP because it's not configured to do so, because it's not, the IPAM is not in charge of the cluster network.
Okay.
It's the Kubernetes itself who does that.
So in that case, the SB, so in that case, the SBI would be.
You just put it on a secondary
Yeah,
thing like the
oh
others.
no, so in this case, the SBI would now register an IP address that is allocated by you,
IPAM. Yes.
by the IPAM. And then so is NRF in that case. Then that always has to be
and in that case, you have full control and it's all fine, right?
And then we have to correspondingly create NADs for those. Okay.
Yeah, but you will get them from me. Yeah? I mean, by default, I allocate an NAD for every interface. Even at 11, you get it. I mean, you could do something to say, okay, this network don't allocate it, but then you have to take care of all that stuff yourself.
Okay.
So I believe for R1, it's better to do everything in secondary IPs, and then everything will be sorted without any challenges. And we can then look at optimizing it further, but there is a whole pile of issues that you have to deal with if you don't.
Mm-hmm. Okay. Yeah, I thought I thought it was a solved problem that we can.
No, the problem is you have to configure all of the things yourself, and then it's not
true.
as plug and play.
But this is outside the scope of Netfuel, basically, because the cloud, because now if it's on Kubernetes, the cloud provider would have to allocate that IP address for them.
Yes, correct. So we are, and we have no control. So is it possible to make that work?
We have to create something to control that, basically. So we have to
correct. So it's solvable, but it's a whole pile of things that you have to look at, and it's not so straightforward.
Okay. Yeah, we can do that. That's fine.
I think for the POC, for the R1, it's easiest to put everything in secondary, and then we have all control of everything, and then
Okay.
So what does that mean? In terms
for you, it doesn't matter. For you, you, it doesn't matter.
Yeah. So that means we'll be creating a bunch of a lot more, annotations for the NADs is a lot larger now.
A lot, not right, because you only
not a lot. One more actually in here.
Yeah, actually one. Yeah, it's just one
more. Or maybe a little more than one more, but depends on whether or not we'll be doing anything on.
Wait, back up a little. Go to the other window that you were sharing.
Sorry.
One right behind us.
So it could be. Microsoft did a good job. It's just the same size of image. Yeah. So so if we are going to bring up all the other guys, then you have to create several of these too.
But so for each of them, how does it work in SMF? Can they work with for each of them, they create an NAD. Is that the way it works?
I don't simply. If we don't care about the N axis, and anything that goes on the service bus, we just bind to the same IP address, which is how you would do it if it's on a Kubernetes anyway.
That's what we do.
Okay. Yeah. So N7 and N10 on SMF is basically the same IP. Actually, even N11. So all these guys would be all going to the same IP. So we basically created one NADs for a service interface, and then creating one for a specific N4 interface, and I think we should be good. Yeah, let's do that.
Okay.
So we treat the service bus as a NAD plugin, but then we don't create a different service IP just for different NX interfaces.
You give them all the same.
Yeah, we're basically they all bind the same because they all use XGP anyway, so that's not big deal. Okay. That sounds good.
So back to this window. I understand what you guys just said. I'm not so sure how to translate that to the NAD in here.
So what you will get from us in specialization, Anna, is the following: you get a UPF deployment with interfaces And for each of the interface, you will have a corresponding NAD, and the name will be one-to-one mapped.
Okay.
And so you have to, in your deployment, you have to put those annotations that are for each of these interfaces. You have to add these annotations into your deployment, in your deployment spec.
Yep.
Yeah. So the package would give you the SMF related deployment. Actually, no, SMF deployment itself would have a list of interfaces.
Yep.
That are hooked up with your SMF deployment, and then from that interfaces, each of this would have reference to the NADs that are corresponding to that interface, and then you only have to create the annotations, the annotation here. So the interface name and interface name itself would both be given to you as part of the SMF deployment in this case.
So the get NAD method would read those and add them or map them to the
Yeah. So get NAD is a bad name, I guess, in this case. But
yeah.
it is a good enough name because it actually gives you the annotation, the NAD annotations. So this would be creating by going through something a little nicer, hopefully. Because this has a difference between. So what Vim did is to basically make all of this into a single list of interfaces. So there's no distinguishing factor between N3, N4, and N9. So you just see a list of interfaces and you just create.
But the name will be N3, N4, and 5.
Yeah,
so
the name would have an annotation. The name would be there, but
but
then for you basically see a list of interfaces. So you'll be creating annotations based on those informations and then fan it out and then create it out. That should be good enough for now.
Okay. I'll have to go muck with it and see if I'm
still
fuzzy in my head.
So in that case, you can ignore. I'm still on AMF, but then yours is pretty much the same. SMF, the config map is a little more complicated. We can go to that later. But then you can ignore this for now. To bring up the pod, you're not waiting for NLF because there's no way for you to reach NLF yet. We're not bringing up the NLF anyway. So ignore this, but make a note on your code that you have to add that in the future, so that you can make the dependencies that way. And then your containers is, so the image, just like UPF, will be coming from an image config also. And then your container ports is one of the ports are, these two ports come from SBI. So it happens to be 80. And then the N2 port is also fixed, so you can just use that. It's an SDTP port. And then you can just hard code that into your environment. That's okay. And then so is the mount path. So this is for now, as you see from my old UPF code, I have a separate functions to derive this. I think the latest thinking is the vendor package would contain that information moving forward, because we don't want operators to take capacity and start calculating things because it may not have that. That would mean that every time you qualified a different capacity capabilities, you would have to upgrade your controllers. So the current thinking is that may actually come from the vendor package. The vendor package would be something like UPF for Nephew Cloud, from 35GC, size large. Large would cover anything from 1 up 10 down to, let's say, 2 up 20 down or something like that. And then if you fall within that range, that package would contain information on what the CPU and memory requirements are. So you don't have to derive that from the operator. I think that's the one thing that is a pretty good suggestion. that we'll implement moving forward. And then the volume is the config map. So that's pretty much it for AMF. So AMF is actually pretty simple. I mean, yeah.
Yeah, we got most of
It's
the
a good
things.
first step to get something going. Yeah. Yeah, go ahead, Vishal.
Yeah, this resources what I didn't get much. So we have to like how.
Yeah.
We have
So
to
if you look at the code that I wrote now, at the time when I wrote this, my my wish at that time, my goal is that the operator is so smart that it will be able to take the capacity information and then map that into how much CPU memory I need. So this is actually, to be honest, a little more multidimensional than just that. You would, as an operator, to make that decisions of how much CPU and memory you need, you may actually have to understand you are running on a particular type of nodes on a particular type of cloud. You know, in order to get to that information. So it probably is better when that information would come directly from the vendor package, because the expectation now is the vendor would say that I have my bunch of UPFs that is going to run on AWS Outpost, and then for a Nitro-based engine, then I for that to run at this capacity, this would be the resource I need, and then the vendor and AWS would do the testing to qualify this, and then they can just code that into the package. So they would release a package specifically for UPF that can satisfy this capacity requirement from vendor X, that would run on Outpost, and then they would create those resource requirements as part of the package. So for now you can just follow this. It's okay. For you guys to kick off, just follow this. Just hard code it. But then in the future, the expectation is it would come from the package. From the package, they would tell you many things actually beyond this. They would tell you, do we need any isolated CPUs? And do we go SRIOV, in which case you create it. And somewhere in management cluster, they would generate NADs that points to SRIOV versus not, and so on, right? So
you mentioned that in the future, or you were thinking that you can interrogate the node properties and find out that information.
So doing something simple, we expect vendors to be able to, well, not able to, but vendors and cloud providers work together to qualify what they need, the resource they need for this deployment capacity, the capacity associated with that deployment. And then they would, instead of having them upgrade an operator every time they figure out how to do something, it would be probably better to encode that into the package. So the package would come from that, because right now when you fetch a package, that package would be for particular cloud platform or particular node, even node type, and for a particular UPF size, if you will, or flavor. So we'll group it into like 3 or 4 different flavors or whatever, a very small number of flavors.
This may be
extra large, medium, and so on, right?
Yeah, got it.
Something like that. And then they would encode that information of what are the resource needs, because me as Ericsson and you as Amazon has already figured out how to do that, and then I'll encode it inside the package, and then the operators simply take that information and push that into whatever they need to push that.
I'm thinking more in terms of the node that is hosting this. You can interrogate, right? You can make syscall to the kernel.
Yeah. So let's think about it. Well, I mean, do that like way later. So for now,
No, yeah, I'm
it's a
just
lot simpler.
exploring.
Yeah.
Because
So
if you
this
take it a step further, some of this network function can be hosted on DPU, and there are different ways of interrogating a test that those nodes are what they are and what they can support. And that tie back to ORAN. That's where I was going in my head.
Mm-hmm.
The ORAN
Cool.
LPU
Yeah.
logical
We'll figure that out later. But then for now,
Okay.
to get you guys started writing these controllers, this is pretty much what it is.
Mhm.
I hope that's a good intro to get things going. And obviously,
Yeah.
I would imagine if you have bump into any things, you can ping me on Slack and things.
Can you post a link to this file that you're looking at, just for reference?
The link to this file.
This is the, I can't read it. That's why.
Oh yeah,
UPS
this is just a regular. Yeah, this is just a regular. I'll put it on Slack. It's a little
Okay.
easier, because otherwise,
this
end of meetings, you'll be losing this already.
Yeah.
So
No, this is Nephew Prowl.
This is. So this is the file.
Okay.
Nephew Prowl. So this is the UPF controller, the latest UPF deployment controller.
FreeFi-GC. Okay.
From FreeFi-GC.
Yeah.
Yeah, FreeFi-GC is
project,
strikingly simple, because they just ended with some sort of Kubernetes. They used pure config map, and then for configurations, and then Dennis is here too, and then they're using just deployments and servers and things. So
Question: the service creation from in the controller, is there any sample code I can look at how to do that?
Oh, I can write one. It's okay. I can write one. It's okay.
Or point me to the API documentation.
Yeah. So where do I
have an example in another repo. Yeah, Dennis is here.
I think I have.
Oh, Dennis is on.
That's great. Oh, you have a service example already? Okay.
Yeah,
cool.
Exactly.
Dennis has all kinds of stuff. You can
Yeah.
just rely on him to do all kinds of things.
Oh, okay. In that case, do all the work. We'll take the credit. Can you put that in Slack, Denny?
Yeah, sure.
Thanks.
Yeah, so I have an API somewhere, but then my computer recently rebooted, so it may not even be there anymore.
Oh, no worries.
Yeah.
I just need something to look at.
Yeah, so I needed to, actually, to be fair.
Yeah, cool.
I needed to, but all the things you saw me wrote over here, I had to go to Kubernetes documents to know what they really are called.
Yeah.
Right, directly. Yeah.
I just put an example there.
Yeah.
Yeah, I learned best by looking at code and trying to figure it out. So cool.
Yeah, because I have to know what the views are called, and are they things. Yeah.
Because basically I'm too lazy to go look at the Kubernetes.
Yeah, I basically just did that. Yeah.
Okay, thanks.
And so the service deployment and config map, that would basically be it for you guys for AMF and SMF, actually, in this case. Yep. It's just that I would have to say what are they doing for pods? Oh, this is a busy ball. This is wget pod. This is testing. Forget that. Forget this. It's just that for config map, there's SMF turns out to be a lot more difficult, a lot more complicated. One of the things that
are we doing config map like here inside controller, or like as Tal was like referring that it should be somewhere else, or like he doesn't like to do it like we did it for UPF? You remember that discussion? So the question is if we do it here or somewhere else.
Yeah, I would vote to do it here to get it working. Then we can figure out.
I mean, no, for R1, let's not jump around and change our mind, left and right when we have working code. So we go with this. The reason why is once we jump to day 2, you regenerate the config map.
Yep.
and then kill the pod. Hopefully not kill it, and kill the pod and bring it back up. So those probably would be nice to be done directly on here, so we can monitor it more closely. And then we can update status to see what the, to update your uptimes and all that stuff during the thing. So it should be, I do believe, I think from day one, since John and I kind of started the product side of the project, John and I had disagreements on where things are supposed to go all the time. But then in terms of network function specific configurations, we never deviated. That squarely belongs to the operator, the network function operator. We never had any second thoughts on that at all.
No, I would have loved to listen to you and John debate.
Anyway. So, and no, I built the first thing purely listening to him and completely shift left. But even that one, there's an operator that generates configurations.
Yeah, I remember we were talking about it back in November.
Yeah, at that point, again, that was pre-Porch. At that point, those cap functions are, are so limited that they kind of couldn't do anything.
Yeah, I'm not even tracking any of that discussion right now.
So anyway, but more than anything else, one of the things that you need is the list of UPFs.
Yes.
We ask Orange, and then again, none of us is a 3.5GC config expert. So we defer to Orange folks telling us, and then according to them, you have to explicitly tell them what all the N4 IP addresses are on the UPFs that you connected to this SMF.
Right.
And also, as it turns out, you have to also tell them your N6 IP address that goes out to the internet.
Yeah.
That basically
that
basically means
we probably need to add something in the spec to do that, right?
Yeah. It should be part of the spec, the same as part of the
so it should be part of the 3.5GC specific extension.
No, I think because you don't know, right? Because we have to give it to you.
Yeah.
Because we allocate the IPs for the SMF, so for the UPF. So
yeah.
You'll have to give it. So we will have to give it to you. So my thought is that I'll give you a peer list with interfaces with UPF. So you have a UPF name, and then the associated IP with the respective interface.
To SMF, right?
No, so in AMFDeployment, I think we should make it generic. There is today you have an interface list.
Mm-hmm.
What you will get, you get a peer list, and in the peer list you get the respective peers. Okay. So UPFs as well as the respective interfaces, which would be N4 for now, right?
Mm-hmm. And my controller would read the AMFDeployment and get that list, parse it, and apply it to my deployment.
And you just apply to this list. Yeah, that's it.
Bind to it or okay, got it.
Yeah, you just update. So you go through the list and you basically add those things here, basically.
Yeah. So you would have to tell us that those are a particular NF type that you're connected to.
Yeah, so I'll give you a peer list. So we have to design a little bit that thing, but for me it was a peer list with the type NF type, right? So
because SMF is connected to AMF and UPF, and among that some other crap.
But wait a minute. So I think So my understanding is there is a specific need for SMF to UPF, whereas for AMF to SMF it's all going via the service.
Yeah, it's just right. Simple. So you're not giving us a. So your only peer list is the things that are needed, but not so much. Here is how it would work. It's not like a topology mapping that you're giving us, but then you're giving us saying that we understand that you need it because SMF has dependencies on the UPF IP addresses, and therefore I'm giving you a peer list because I know this, but not like generic give you a peer list by saying that, oh, I know all your peers are here, so I'm giving you all this list.
Here is how it works. So the whole flow works, in my view, is that the package that we get for SMF contains the IP allocations, right, that are needed for N4 for UPF. So what I do in specialization, I look up those IPs in IPAM, and those have a special annotation that I'm using to add them to the peer list. So whatever you put into the package that has that annotation, I'm going to give you the respective metadata associated with it.
When you say you, then you're talking about the package group, right? The
Specialization. So the first thing is, in the package of SMF, there will be some, let's say, IP allocations with special annotation that says it's for a peer, and here is some metadata. And so I'm going to use that to look up that IP in the IPAM. So that I know what IP was allocated for the UPF, right? Yep. I get that back, and when I do the specialization, I add that into that peer list we just discussed, so that you can look it up, and then that's how we can do, so how we can resolve the whole flow.
Okay.
That actually goes all the way out to the other piece that I own, which is NF topology.
Yeah, so
NF topology would have to give you the topological information.
Correct. So you should actually in the package add those things in it. And
I have to give you those conditions basically to tell you.
Yes, correct. So and then I'll add the whole thing. Not the conditions, just a CR that says, "Hey, I need a UPF."
Because I thought last time we talked, you were saying that you want the SMF package to depend on those UPF package to ensure that you have already allocated the UPF. The IP
yes, but it will happen automatically. So it happens automatically by. If you put
but we're having automatic because of conditions. So someone
not really conditions. So it's the resource, right? So it's a CR. So it's basically an IP allocation CR that you put in there, right? With a query parameter or something like that, right? And you say, here is the UPF specifics associated with it, right? I'm going to look up that CR in the IPAM, get a return back, right? And then I will add that metadata.
I see. So at that point, when you generate, So when that happens, So if for whatever reasons the SMF package is being processed first, before you allocate something out of this, because
it will never resolve.
This is post fan out, right? So when you after fan out, if somehow you process the SMF first, but
it doesn't. It will never resolve.
But then you're looking at one of the UPF, that IPAM status points to that hasn't happened yet, and then you
correct. So it will SMF will hold. So I cannot.
The SMF will hold. Okay, you can hold that way. Okay.
Yes.
So I don't. So meaning that I don't have to. The NF topology doesn't have to explicitly set a condition of telling you that you have to wait for this UPF.
See, all these conditions I do myself because it's a way to orchestrate the specialization, right? I just need CRs, right? So give me CRs and I will resolve them, and then it's very clear delineation. You say these are the requirements that I have for this package. I'm going to resolve them, right? And then you get them. So it's clean. I think it's very clean way of doing it.
Because I'm writing a doc for the NF topology. I was thinking, should I set all the conditions? But then if I set conditions,
just
post fan out.
At the CRs that you need. So because I need some metadata in that CR to do that lookup, right? So I need some metadata there. We can discuss that later because otherwise I need to find.
This is probably not an operator teams thing. So we should talk about that later.
Yeah, it's not for this, but that's high level how I think it works. And then we have very, let's say, nice, clean separations. And
it is one of the things I'm thinking about right now on writing the doc, which is obviously to solve this particular problem. At your level, you would have to know the topology.
Not really the topology. I just need to.
You have to know the peers. Basically, is part of the topology. So
you need to say. You need to basically say where the UPF was.
Well, we have to tell you this particular SMF are expected to be connected to this list of UPFs, basically.
Yes, right? you have to give UPF. So for me, the CR is IP allocation because that's the one that we use to resolve IP. And in that, you have to say the location of the UPF. That's basically it.
Okay.
And if you do that, that's all we need. Yeah.
Okay. So, going back to the operator team, once you get to this information, somehow between us, we'll get you a list of peers. So this only pertains to SMF and for now. So for SMF, you know your dependencies on UPF. So I guess Vim in this case only gives it to you on SMF packages, and that only pertains to UPFs. And for that, they'll give you a list of interfaces that are. So Vim will still have to give you a distinguishing the difference between the interface that are for N6 versus N4.
Yes.
Yeah, it's the interface name and associated.
Yeah, no. So because in this case, your this IP address is the N4. So when you look at the peer would have a IP address that is used because you have to connect it to it that way. You meaning SMF. So when you see this, there's an IP address which is for you to connect to the peer, but then there's also an IP address that you care from the peer, but it's not your connection point. So again, the structure on that peer needs to have that information of it's telling you the DNN and the CIDR on that DNN. Actually, this is an IP address pool. This is not the IP address used. So you have to know the pool of the DNN. Okay.
So you were confusing me. This is a pool. This is the DNN pool.
This is the data network pool. Yeah. So this is not N6. This is the pool being used on that DN.
Isn't this the DNN for?
No, this is internet.
SSAI?
I mean, we only have one DNN all the time. So all the configuration you see from Orange is only one DNN.
But my question last night was. My question last night was N4.
Go ahead. Dennis.
Well, I wanted to say that like in UPF right now we have two UPFs in config map and in CR itself. So I guess you can follow kind of the same principles because you created two UPFs. Exactly.
And then they point to two internets, but then same name, but then they're on different CIDR.
IP addresses. Different pools. So and also inside the UPF, I have two different DNNs as well.
Okay. Well, Internet 1 and Internet 2.
Well, I call it Internet and private, whatever. You can give names. The only thing is that they need to have different CIDRs in the pools because IP addressing will be different for use.
Okay. Yeah, but then I guess in this case for Vim it has to be under has a UPF, but it's basically associated informations. It should be on DNN somehow.
See, the way it's associated is with the VPC, with the name of the network, right? So that's your association. And so, but if you say allocate 10 pools, I'll give you 10 pools, right? So I don't care.
Okay.
35GC supports.
This is basically just a network, so you should be able to just get that. It has nothing to do with an interface. Yeah, I mean, initially I thought they were exposing N6, but in this case they're not exposing N6. They're just exposing the IP address associated with the DN. So that's fine.
Yeah. Just one thing. 35GC supports
okay. So
maximum.
Speaking too soon. So you need N3.
Yes.
So you do. So for each UPF you have to have multiple interfaces outside of connected IP. There's also an IP for N3 or N9, basically, in this case.
Just one limitation. 35GC UPF supports maximum nine DNNs. There is the bug or GitHub issue in 35GC code.
Okay.
It's fine. Then only one is enough for us right now.
For sure.
Thank you for finding that out, Dennis. It's noted. But then I don't think we'll ever hit it.
When I was looking for multiple DNNs, I just Google and found the issue. So I didn't implement them in any limitations, but
I did not know that. I did not know that, and I suspect even the Orange guys don't know that. So good finding. I don't think for our one we'll hit it.
Yeah, we are happy that we get one to work. But it's indeed good to know. Yeah.
Yeah, it is. It's great information. Yeah. So yeah, in order for Vim, we would need we'll need at least the N3 for that UPF.
Yeah. So for us.
So we'll think about how you want to model this. So obviously, the easiest way to model is the connected point, which is the N4. But then now you have other associated IP address under this peer.
But you have.
But you have to also give us an interface type in case we use IUPF. Yeah. So it's not generic. You have to make it specific for a UPF then.
So at the moment we give interfaces N3. So there is a name, right? And the name says it all at the moment. If we need more metadata, we need to add an attribute.
Yeah, we can do that. We can extract it from just the name.
But I think N3.
If you put that as a prefix, that would be easier. So we can do like a split using the first field off of a dash or something.
Oh, but for us, so the way I give it to you is a list, right? And the list has a name, so it will be name N3, it will be name N4, it will be name N6.
Okay, so you just flatly name it N3, N4.
Yeah, correct.
Not
so
like,
you just
not like N3 dash blah.
I don't even do that. I just give whatever is in
because I did that. I did that on the interface name.
But you can do that yourself if you want, right? But for me, it's just N3, N6, whatever prefix or whatever you want to do it.
So because you're assuming one each, right?
Yes, for now, that's the idea.
Okay. Yeah.
Because if you have multi-pot, you basically get an additional one for each other pot, right? So it's still N1, N3, but then...
no. So for Free5GC, I haven't seen a case where they can support more than one anyway for any of the N whatever interface. Yeah, so that's
okay. Yeah, sure. But that's why, so
modeling wise, of course, you can have it should be at least for N6, it should be multiple.
If you look at Nokia with multi-pot, right, you never name those interfaces N3 because N3 is a loopback for us. So in other words, N3 is behind the interface that we are provisioning.
Okay.
And so if you have
when I work with Nokia, your UPF has multiple pods types, and one of them is MG. The MG, if you create more, I think they're creating more N6.
No, it's a choice you have. You don't have to.
Okay.
It's optional.
Okay.
But the way it would work is it's one per pod, right? So it's never more than one per pod.
Okay.
So in other words, the way it would work is I still with this 1 and 3, it still works because you get more of them into.
Yeah, but the UPF deployment is the entire UPF instance, not the pods. So if you have a lot of
at the moment that's how we modeled it, Steven. But going forward, we could do a per pod thing, right? So I didn't do right now, but that was my thought.
Okay. Anyways, for our one, don't worry about this. One is good. Just go with one. And then so if the interface name is just N3, you can just take that for your interface type, and then that would come with an IP address, and you can just go with that. Oh, even N3 has a DNN? Interesting. And you have to create a topology. So that will somehow give it to you also. Actually, that's not even just a topology. This is basically a directed graph. You go from A to B. But for now, let's not worry too much about any of those. Just get the basic stuff moving that you do have, which are the SPIs and the N4. Just fill those out first. The rest of them, for now, it doesn't matter. Just hard code it. And then for the UE routing piece, this is actually, it's a lot more complicated. I don't know if that really reflects anything because I don't think did Orange create that topology? A GNOB connect to 2 UPFs and then an anchor.
I don't know.
Yeah, I don't think
we need to check their values.yaml Helm charts, because from there we will be able to find if they're doing that or not.
That is true. No, that is true. Actually, yeah, that's right. Because when I grab it, they have 4 UPFs. Actually, when I grab the Helm charts, it generates 4 UPF configs.
Yeah, it should be in values.yaml anyways for Helm charts.
Also, in our case, we don't have IUPF and stuff. Maybe we can simplify this. Yeah, this is UE routing. UE routing is an input to SMF. So they do that as part of the config input. I don't think we'll challenge anything special. So to bring up the SMF pod, you can just keep it as is. So on and Varesh, just keep this hard coded for now. Because the first goal is just to bring up the SMF pod. We'll figure out the networking and everything later. You just need something on your UE routing YAML. So just put that in. Probably would be good enough.
Maybe UE topology later on should.
Yeah, we'll figure out topology. Our topology is not even nearly as complicated. Wim and I never thought about using IUPF and stuff, so I don't think we'll challenge ourselves into doing that. I mean, the distinguishing factor of understanding you have an N3 versus an N9 on different UPFs, that would be cool to do, but then probably not as our first goal. And it sounds more like testing 3.5GC more than testing in Nephew. So
yeah, well, exactly, right. So
yeah,
because
so let's forget this. I mean, it's not. Let's not do something too complicated. Yeah, let's just.
Yeah, and for config maps, if you have lists like in SMF, IMF,
yeah, so just generate those.
You must probably have.
Yeah. Again, for An and Varesh, the first goal is just to bring up the SMF pod using our controllers. So you can just use this one as is. I don't think it will affect anything for now. It should bring up the pod.
Yeah, like in UPF, I use templating for generating this Go templates to generate this config map. So like it's relatively easy. Like you just need to provide correct objects, into render, and then it can find fields and put values into the template. So there is an example for that.
You have move on from my strings replace.
Yeah, exactly. Because I needed to.
I absolutely welcome that, by the way. So obviously I wrote this because I was doing it for a demo.
Yeah.
I mean, otherwise I would have done a YAML. I would have at least done a YAML node instead of using a strings replace. Obviously I was lazy when I wrote it. So
I was looking. I decided not to use YAML, but rather the template, right? Because it's still kind of string rendering, and like I needed at least two different values.
Yeah. Please change my code. It's very embarrassing. Yeah, so other than that, your deployment, again, this is the NAD annotations. You will have that from the deployment piece. Get rid of that for now, for bring up the pod. And
I'm not so sure which file you're showing.
I am. This is the thing that you generate out of the Helm charts. This is a manifest.
Yeah.
Yeah.
Okay.
So if you do a Helm template,
yeah,
it would generate this.
Yeah, I just didn't know where you got this. So.
Because I'll generate myself basically.
Oh, okay.
Yeah. Otherwise, I would put it on web instead of on my computer.
Yeah,
my terminal.
I wasn't sure if this is.
Yeah.
No,
we did the same thing, right? Before the ONE Summit, I show you that this is what your target is, right? Basically. So as we tried that time too, forget this. You don't have to do it for bring up the pod, but do it later when we actually have an NRF running. And it'll probably be pointing to a real IP address, not a name. Other than that, actually, the rest of them seems simple. You need less a lot less than UPF for the deployment piece, so it should be fine. Oh. Any questions?
Nope. Not for now. I'm going to bed.
Okay. So let me see. So
Bim's gone?
for the BIM's still here, I think.
No, I'm here.
Yeah,
I'm awake, so
yeah.
I woke up.
So for Vishal, well, for Rash, Vishal and Ronak, are you guys fine?
Yeah.
With what's next? Yeah. So focus on creating a config map. Yeah, because the next step isn't to bring up the pod first. To create a config map and dump the config map, and then make sure the config map matches what you see here. Not that one for you guys. So make sure the config map matches what you see here. That would be a good first step. So do it on like log or printf. So then you if it matches, then that's a good first step. And that's true for everything. That's true for service. That's true for deployment. So you should be able to see the structure that looks exactly like the YAML that you see here. And then once you have that,
what I guess you can do is just like fork that, like, or not fork, like pull clone like orange repo, go into SMF or AMF, like, you know, Helm chart and do Helm template dot, and
yeah,
just
I mean,
gives you
even
like,
that. Like, let me send you guys the files. I mean, you it's okay. I can just get everything expedited much more easily. I can just give it to you. It's probably easier to do. And then yeah, I'll post it here later. So for the manifest that you guys should be targeting. And then once you have that, start coding it to make sure that you can take the AMF or SMF deployment and generate something like this. And that would be like the very good first step. And then the unfortunate part is the AMF and SMF and UPF deployments will likely go over some changes moving forward. But then once you get used to how to generate them, the information you get out of them are pretty much the same. So it should be pretty easy to make modifications after this. Yeah, once you have those, you can then finally invoke the actual function call. What is it? Yeah, you create. Where's it?
So
yeah, so here you can invoke the our_client.create on your config map, our.clients.create on the deployment. Creating deployment right here. Here, run the client on deployment, and then same thing for the servers. And then you should be able to see them when you do a kube control get afterward. And the ultimate beauty is do a get pod and you see the pod up and running. That would be great.
Well, we did it manually for O&E, so
No. I mean, obviously, manually is just
I know it's
just applying. Manually just applying a YAML, but then right now you are applying a SMF and UPF deployment YAML, and then the result should be seeing the pod up through your operator or through your controllers.
What I was trying to say was, I know the YAML created from the FreeFrag GC works. So now it's just a matter of coding the operator to do the same thing.
Mm-hmm. So yeah, that would be ultimate things. You don't go from zero to that. Just go to every single step. Maybe just print the structure out in text format, and then making sure that autofills looks good with like right spacing and stuff. And then yeah, particularly the text things like config map. Sometimes a line there and there and here matters. So yeah. that's actually all for me. So have fun coding. Let me know if you let me know if you have any further questions.
We had agreed last night that we'll meet tomorrow night. Are we still meeting?
If you need something, for sure. And then if you want to sync up and then update on progress. I mean, I'm not I don't want to boss people around. And I'm not, I can't. So I don't want one day turn around and start pinging, hey, what are you guys doing? So I don't want to see that. So happy coding. Have fun doing this because it could be fun. And then there's a lot of things to learn. And then I would say maybe next Tuesday we can sync up a bit. Because it's that would be 1 week into the current sprint and 1 week away from the end of the sprint. So we should kind of meet up and see where we are and whether or not you guys need help. So Denny's, myself can all jump in and help. I mean, speaking for Denny's, maybe he doesn't have that much time, but then he's obviously very well versed into the whole thing now, and then any of us can help, and hopefully we can get something going by the end of the sprint. As we talked about, the hope, the dream is that at the end of the sprint we can start doing some light level integrations with Vim stuff. That would be awesome. But then before we get to there, obviously our own within a workload clusters, when you apply your XXX deployment, it should bring up the pod. So we should be able to see that at the very least. So if we get to that point, and it's check-inable, meaning that all unit tests and things are in place, that would be really amazing.
Yeah, actually, if you can have a meeting tomorrow, I need to understand what I have to change for UPF, because after our meeting on Tuesday, with Tal and Vim, I understood that my spec is not good, right? Because we have obviously used something which we had before, but it does not align with the spec which Vim is going to give to UPF.
Yeah. So that's the big one. So that's the one that we should sync up with Vim also.
Yeah, so if you can arrange a meeting, and then change it, and I start coding.
Amazingly, both of you guys in Europe, so I have to kind of accommodate.
Yeah, we can. Dennis, I mean, you can reach out to me. So, what is the question? Sorry, I was.
So the UPF right now uses the old UPF deployment, simply because
you want to
the code that is there. So we would like to see taking some of the things you have. And then we have to, obviously from our side, we also gauge whether or not that's good enough for us to get something going. So maybe there'll be some feedback, but then we'll probably
sure. And I'm not saying it's perfect what we did, but I found the hard coding of N3 and so on. It's a bit hard to parse and stuff like that, and it's not generic enough. So,
but what do you mean hard coding? So
he doesn't want a UPF deployment that holds distinguishing between an N3, N4, and N6, and then
okay.
Yeah, okay. It's basically just generic interface config.
It's not good to because our goal was to make them generic, right? The CR. So if you go tomorrow to SD1, right, and they name their interfaces blah or A, B, and C, then we should not change the spec for that, right? You see, that was the whole idea, right? So,
but I still need to get some type of the interface, right? You give me a list of interfaces, but there will be some kind of type of that interface inside,
so at the moment, the idea is the name gives you the name is kind of associated to the type, so the name would be N3.
Okay.
So that's
there will be a string which I can parse inside the name of the interface and deduct it.
Yeah, so in the name of so at the moment, if you look to the package that I can share my screen if you want.
Yeah,
please, give me the link to that package, and then I will be able to kind of to sync them.
Yeah, actually, if you want that, you see my screen, right?
Yeah.
GitHub. Wait, so at the moment you see the starting package, GitHub Nephew. that's what we checked in, right? So at the moment, where is it? Repositories, example, free 5GC packages. And then here you have a UPF, you have one for, so here you see interface and tree. So what I'm doing right now, this interface here, I just copy in the interface spec one by one.
Okay,
See?
one by one. Yeah. And
So
it has a name N3, right?
Yes, and so if you look to, I was just doing some testing with my code here. So I take that package and I start to specialize it, if you will, right? So you see here, the interface N3. If I do an IP allocation, it's also N3, you see?
Mm-hmm.
And network attachment definition, I mean, you don't see it because there is a second function that does it, but you see that the network attachment definition name is also N3. So at the moment, I'm just in specialization, use that name, and I basically, in all the resources that are associated with it, it has the same name.
Okay, cool. Then I'm going to use the same logic then in UPF. Like, I'm going to rely on the interface name. I'm going to check your files. So I can then try to kind of align like to the interface name in my case. Okay, good.
And then we have a consistent, so it's because for me, you can of course prepend or do whatever or add suffixes or prefixes to that name, given your context. But for me, because you see, for example, in IP allocation, I allocate within this site. So so in the IPAM, it says it's an N6, but it's associated with this site. And as such, I know the context, you see?
Yeah, okay. What about N6 and DNNs? How do I get DNN name?
So DNN is like this. So it's internet, right?
Uh-huh.
So internet, and then so internet is the name. So again, DNN will have an internet name, right?
Uh-huh. Uh-huh.
And the pool will be like this, but here you will get an IP pool with a prefix.
I need CIDR here as well. Okay.
So how do you associate that data network to your UPF?
I think I just use N6 interface, like which.
Yeah. So the way it's structured into the AMFDeployment, right? Okay. So if you look to the spec that I did, this network instance, right? So if you look to UPF deployment, where did I do that? Long time ago. So the way it was designed was like this. Let me take the CRD document, right? Where do I find CRD? Google Drive, I think. Nephew Wiki. So network automation, Drive here, and then CRD, right? Document here. So the way it was designed is there is a network in, so wait. Here. Yes, so the way it was designed was the following, is that
So basically, I'm going to, follow exactly this spec, right? So I need to,
correct.
write the code for this spec. Okay, cool.
So the way it was designed is the following. Each of these things are associated with a network instance, you see? So this network instance has a set of interfaces as well as a DNN associated. So what you will see is because N6 will have VPC internet and DNN also is associated with VPC internet. What we will do is we give you a network instance with name VPC internet, and in that you see interface N6 and its associated DNNs. You see?
Okay. So basically, then that association is just easy as a network instance name, right? So I can.
Correct. So what you should do, Dennis, is to get all the interfaces. You walk through all these network instances, right? Because there is, right? I believe. So you see, there is network instance. So there is a link between the two, and that's OpenConfig does that. So I took it from OpenConfig. So you have a flat interface list, and that interface, so that's interfaces, but then the association on how DNN and interfaces are there is done through network instance.
Okay, so I have to check in like if yeah, I have DNN in network instance, and if there is interface like N6 or whatever, which is in interface list, okay, there are some check-ins has to be done.
Yeah, the association of DNN to the interface is done through network instance.
But interface has to exist in the interfaces list,
yes,
right?
Yeah, correct.
Otherwise,
so this,
if it's not there, I have to.
That's correct. Yeah. And what network instance basically holds a reference between all the interfaces and DNNs it's associated. So this holds it together, right? The interface is just a flat list. That's how OpenConfig does it.
It's kind of I have to rework completely what has been done already. Yes, that's fine. Yeah. Let's take a look in sprint 2 into this.
Yeah.
But for the sake of time, can we actually take then this CRD and already check into APIs?
Yes, I can. Do you want me to? Yeah. So I did not do,
please,
but I
please,
can do,
then there is one PR which I opened to check in UPF, then that has to be canceled. We need to add this one. And then when I code, I'm going to point to this types API file already, so I don't
okay, I will do today. Yeah.
Please, good. I guess we have to design the same stuff for AMF and SMF.
Yeah. So yeah, correct. So at the moment it's called UPF deployment, right? So we'll have a. What I don't know yet is, for me, they are all looking the same right now.
Yeah, they don't look very different. No.
The only difference what we have to add into this, and maybe before I check in, I'll do a little bit of a thinking about it. This peer thing, right? So this peer list, because you need that, right?
Yeah. Well, for SMF, they need it.
Yeah, so either I put the peer list in network instance, which is where they actually belong in my view. So my current thought was put peer. So peers here, which have then a structure, it's basically a list of things with its associated IP and a name, which would be UPF or something like that.
And as far as peers has to be part of the networks, they have to be in the same network as
that's
N6 and N3 interface. Okay, there is another check to see that the IP address of the peer is inside the CIDR, which is given for the
Yes, so that's why it would be done through a network instance, because that's the association to the network. So let me do a little bit of thinking to add that, because then it's immediately complete, right? But I will do today.
Sure. Yeah. Then kind of let's follow the same logic, in future. So guys, if you are giving something to us, so you're establishing the contract between us, instance and the package. So you give us types, and we kind of work with these types.
Okay, yeah, that's fine. I think we had a bit of a back. I thought it was the other way around, but it's okay. I mean, that's fine.
Well, I mean, so in this particular case, it was because we used the old one. Yes. We are what then is this more than anything is just to port the code from PLC side into official repo. In terms of integrating with the package specializations, it will probably be the next step once we get used to what the fields are and what are needed, because we know what we need, obviously. So
but that is already a step further, right? So he could, I think he has the thing running, so he could align right now.
So
right?
now
exactly.
Now is the next step. Now would be the next step of saying that now we know we can port stuff over. We know this code. The old code brings up a UPF instance. So now make sure that we have enough information to generate the same deployments and config map.
Yeah.
Yeah.
Yeah, and BGP is here, by the way, but it's not used, right? So we will not use it, but it's designed to have that in it. So
for 5.3.5GC, I will have just something like function or whatever, or command to do, because
it's a pointer. It could be nil. It's an option.
Yeah, it's nil. So it's omit empty. So if it's not there, it's we will. So in release 1 we will not use it. But Steven wanted to have this for.
No, yeah, I mean eventually, to be honest, this would become probably a generic vendor extension. Generic vendor extension, if you will.
Yeah, this is what for 3.5GC I just kind of do comments that it has to be deployed by the vendor, as Nokia, whoever, Ericsson.
Yeah, but you can do either way, right? So see, in my view, this is a generic way to do BGP config because I took it from OpenConfig. So I did not even, I have no IP.
BGP configuration can be amazingly difficult.
No, I understand, but OpenConfig has standardized stuff, right? So this is the way that all vendors are adhering to that.
Okay.
So that's why, in my view, I'm not saying you can do both, is what I'm trying to say. This could be a generic one, right? But you could still have vendor specific because you can say this is omit, right? And then the package does not contain it, and then the vendor will do it. So that's fine.
So you could,
you can do both with this, is what I'm trying to say.
Yeah, you could associate with the BGP config resource for your UPF for those vendors to support it. But then they can all support the same BGP config resource.
Correct. If at some point we see that there is convergence, we can align, right?
Yeah, we can do that. But then obviously there are a lot of practically all the open source 5GC like Magma and others
they don't have it.
They don't support BGP. So
but then you basically don't set this, right? So that's fine. And
so there are two ways to do that, right? So one of these would be make this optional, and then now you make it a pointer already. So optional a pointer, you don't have to even set it inside your YAML, and then the second way would be it's a resource that you can choose to include on your vendor package. You can do it either way.
By the way, the vendor ref is already in it. You see?
Yeah. Why do you need a reference to a vendor ref? Oh, you want us to
this
point
was for
to
the image, you remember? So what we discussed?
No, I was thinking, actually that either way is fine.
We can make
all this time we're thinking that using the same,
but
the same name and namespace will be associate all of them using that key basically.
Yeah, but this is a generic GVK reference. So here you can basically associate any object to this that you like, right? So that's the idea here. So you basically have a generic reference to an object that a vendor could supply, right? And you just reference it. So it's generic.
Yeah, but there's only one.
We can have more. We can have a list, by the way.
Yeah, you can have a list.
Yeah.
So for the time being, for this sprint, I'm going to ignore it. But then if we have a list, then we can.
Yeah.
Okay.
I'm gonna drop off.
Oh yeah, go ahead.
Good night. Thanks.
Good night. So Dennis, you're thinking of support. You're actually thinking of how to support image config too, right?
Well, I have an idea already. Kind of, I want to create, like, let's say, image config. There is operator, right? And then I have already created it, and then I provide a path with multiple mappings there. So there is UPF image, SMF image, AMF image, and it has to live in some kind of central namespace, because SMF, AMF, UPF, they will be most probably living in different namespaces.
That's correct.
And then, like, when UPF starts, it goes like looks into that namespace, which will be central for image config and for that, like, path. If it doesn't exist, it just reconciles. If it exists, it gets the path and starts something like that.
No, so when obviously, so if you're creating your deployment for the first time, you definitely have to look for image config somewhere. You have to do that. The question I have though is, if sometime later someone changed image config, you wouldn't be able to. how would you watch it? I guess you're watching it using.
Yes, I'm going to do. I'm going to add a watch. A watch watches, and look if there is a change. But what I was thinking that, like, we need some kind of a flag or spec for UPF IMF, and which says, is it allowed to update based on the image config change? Because like not everybody is going to want to, like, whatever is pushed like into image configs, and it immediately kind of propagates like into, it might into like, production. In production, it might be cause some interruptions, right? Like there should be some
canary. You want to do that in canary normally, yeah.
So, like, well, for the time being, I'm going to implement without this logic, but at some point we might want to add something like that.
We want to have a generic infrastructure where if a change occurs, we'll be able to detect a change on that vendor extension, basically. So, for example, stretch goal, I'm guessing now, if somewhere in R1 we want to add a UPF instance into the topology, and then connect to the same SMF, then the SMF will get updated.
The SMF will have to restart because of the config map change.
So things need to be restarted for sure. But then I'm just saying, but then the SMF controller would have to be able to detect that change.
Yes.
Even though if it's vendor extension.
They will be able. They should do it is because they will get a new NF deployment, right? SMF deployment, because what you will see is that the peer. There will be another peer in that.
It depends on where you put it. So earlier I thought we were going to put it into a vendor extension, but then now you're thinking of putting that into a generic deployment. In which case,
because if it's a vendor extension, I need to write a specific function for it, and this is generic infrastructure that we already have. So it would be not so good to do it at a vendor extension, right? So that's, I think, a way better architecture in my view. And it shows
because for example, for you guys, for Nokia, adding a UPF instance to SMF does not affect the SMF. It basically
because the way it works for us,
you auto detect it, right? Basically.
So the UPF, we just provision a peer IP, right? And we just need to know the SMF, and the UPF will discover.
We'll directly contact it, right? This is
correct. So,
this is the free file juicy weirdness, right? So this is
but so here is my view, Stephen, right? Because we will have other requirements where you have some kind of relationship. Now, irrespective of that, what we are basically doing is the following: it's a way to resolve inter-NF resources, right? That's what we are showing, right? Now for SMF it's needed, but even for us, let's say even for Nokia, right? We need this because so when you deploy UPF, I need to know it's the reverse operation. I need to know which SMF I need to go to. You see? So as such, I need to do a lookup of the UPF. I need to
in your case, your peer would be discovering a new SMF, basically. Right?
Correct. So I need to do the other way around. But so what I'm trying to say is that if we build this generic capability inside, which is basically what I just said, it's very simple, right, to do, and we have all the components to do so. As such, we are proving that case already. You see? And is that the only way to do it? No, but at least it's something. It's better than nothing. That's what I'm saying.
Yeah.
You see?
No, I'm okay with that. Yeah, because originally I thought it would be a vendor extension. So just figure if it's vendor extension, then it changes the config map, and then the config map would now be changed by two components: the extension controller and this controller. And in which case we'll have to. So Dennis and I talked when we talked last week. I think we were saying that whether or not he actually figure out a way of watching a secondary resource. A different resource that you don't reconcile against on the same controller, in which case we can.
But you see, it becomes way more complicated, right? If we do it in a generic way, you get all of this out of the box, right?
Yeah, but then I think eventually we still need to. I think we still need to have a way where if we have a centralized entity that owns the resource, but I guess right now it's not urgent because we haven't seen the problem yet. At that point, I thought we have a problem where config map is owned by one controller, but then there's their extension resource where we affect the config map, in which case we'll have to have one controller writing to a config map, and the other one is basically just detecting changes. And then it seems like it's okay to be able to detect changes too on the same controller. And then you still have a single funneling controllers to write the config map. So that was the thing I was concerned about last week when Dennis and I talked. I thought, hey, if we have a second thing that needs to update a config map or updates the deployment, then we would have to have signals between different controllers.
In different clusters,
it's possible.
right?
No.
In different clusters.
In different clusters.
Same cluster. No, not in
No, because could it not be that? I mean, you have to know SMF on the other side, right? Or I'm not maybe getting the.
I don't know. So originally, let's say for argument's sake, the thinking is instead of doing generic, we'll push the list of UPF as a vendor extension, a 3.5GC specific vendor extensions for SMF. Right, and then if we do that, because this is a vendor extension, so the generic SMF deployment would not have this. The controller is watching the SMF deployment, so the controller that watches the SMF deployment owns the config map and the deployment object. So if someone changes the number of UPFs associated with that SMF on the 3.5GC vendor extension resource, then the second controller that watches that resource we try to update the config map. In which case that would not be good. Right?
No, that would be really
that would not be good. So at that point, the one thing I want to make sure is one controller owns the resources for sure. But then if other controllers are watching, they have to be a way to signal the controller that owns the resource that something has changed. So let's recalculate the entire config map.
Yeah. Now, what this gives, so this we probably need to put the list, right? Is give you that link between those resources that are associated with this deployment, right? So this list should give you vendor extensions, but the idea is not to use. Yeah, I don't know what they will do, but normally, if you have something like this, that means the controller that takes this. I'm assuming for the time being that these references to CRs that are here would never, it's not really a controller associated with it. It's basically in our shift left approach, the changes to that config map would come from the management cluster, but you would have to detect the change, of course, if there is a change that would be applied. You see?
Yeah.
But here
config map is generated by the operator in this case.
Yes, in your case, yes.
But then so when you have if whatever the extension is, that if you have an extension change, the pointer doesn't help you because the pointer doesn't change in this case. So the reference doesn't change.
See, even for these become watches that you have to put on these resources, right? That's
so that's what Dennis was talking about. See, he's also going to watch the image config, for example, on UPF.
Correct. Yeah, that's what you have to do with these. So with these, for every reference you get, you have to put a watch.
Yeah.
And then that would give you change information.
Yeah. And then your reconcile would be waking up and you fetch all of them to see whether or not they need to be updated, basically.
Yeah, you basically read them and you
actually, basically you read them and then.
See, that's why I have my diff library that we are putting in. You could use that.
It's very interesting. Yeah, right now config map isn't. So Kubernetes is not smart enough to know if config map has changed or not. so if you tell them create, they'll create it again. If they do an update, they update, even though if the data is exactly the same. So it's not. So you kind of have to see whether or not it needs to be updated to make that decision.
So that's what for example, in my SDK that I built, right, that library is doing that for you. So the vendor that so it's basically hidden from the operator. Operator meaning the code that Dennis is writing. So it's hidden for you. So you basically say, hey, here are some new config maps. Figure out what I need to do and update it. And the library will take care of it. or it will tell you, here is the changes, please apply, do whatever I told you. But okay, yeah, that's
yeah, I have just administrative questions. So like we still go with image config because Tal was kind of skeptical about this stuff. He said like, he didn't know and like, he goes somewhere else. So we still work on.
Yes. So my view of my understanding of what Tal was referring to is the following. He was, I think, aligned with me, I think, on this one, right? Because so image config is a CR, right? Of a certain type and blah, 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 blah. And we call it, let's say, probably free5gc. So there will be a free5gc with image config or something. Free5gc API version v1 alpha 1 image config, right? So, and I think there you put some parameters in. What he was saying is that you should get a reference to that from the UPF deployment, right, spec, rather than doing a hard-coded lookup. So the lookup will become via this pointer reference. You see what I'm saying?
Okay.
So rather than you in the code looking up image config with the API version, blah, 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 just add you would basically be instructed via the UPF deployment spec to say, hey, this deployment has a dependency or has a reference towards this spec. So, and by you getting to know that, you know what to look up and do something with that.
Okay, fair. But then, like you, how in like in the deployment spec you provide it, like to the controller as a field in the types in the spec, or like how's the reference?
So the reference looks like it's a group version kind namespace. That's what it is.
And like there are this one, right? And there are some kind of APIs for like behind that reference. There is an object which I can query.
Correct. Yeah, that's correct.
Well, then I need an API for that stuff. How I can query it? Who can?
So basically what we do, so this is a reference GVK, right? I have some code somewhere that has a library that does lookups from the API server, and you can basically query that thing. I'll have to find where I did that code. But with this information, you can do a generic lookup to the API server and get the object straight.
Okay. Well, if you can provide that API, then yeah, I'm going to use it, but it has to exist somewhere. So when I deploy UPF in my testing, I need to have that working already, right?
Yeah. So the API, what I'm referring to is the Kubernetes API, right? Because the image config would be applied to the Kubernetes API by config sync. Right?
You mean that we still have image config, it will be there, but then there will be some kind of another object which will be queried, for this, to get the.
Yeah, so the flow will be the following, right? Image config will come via the package. Config sync will apply to the cluster as well as UPF deployment. You are reconciled by UPF deployment, right? So when you see UPF deployment, you will be saying, in this reference, it will say, hey, there is an image config that is also relevant for you, right? Please look at this. That's what this thing does, right?
Okay.
And then and probably what Steven says, we need to have a list of these, right? Because there might be right? So we'll make this a list, right? But for each of them, you have to look up this resource. So let's say if that resource is not there, you should probably stop the reconciliation, similar to how we discussed the NAD one, right? So, and then once you fetch them, you put a watch there, and as such, you get changed information, right? So you get, but that's the idea is that what Tal was referring to, in my view, is not a hard-coded in the code to say, hey,
fair enough, so like, in sake of I'm just thinking what should I do, right? So if I right now create image config, CR, I deploy it works, right? And then I still don't have a reference, right? I can put something like a stub, right? I create a reference object and say it's image config, and if it's there, there in my code, I'm just going to refer to image config and do some kind of hard-coded stuff. But once we have a code for this extension, then kind of I'm going to rewrite it to do
just
correct operation.
You replace that, correct.
Cool. That makes sense.
That's it. But so the kernel of the code does not change. It's just you get the information from one source rather than hard code.
Yeah. So there are a couple of lines, that I'm going to query, not like, image config on my own, but through the reference, right? Through some other. Cool. Yeah, sure. Fair enough.
Yeah. So every time you get your reconcile loop runs, you kind of look at whether or not that image reference has changed. Or you reconstruct the deployment object in this case. And then you can apply it too, because if it doesn't change it, Kubernetes doesn't do anything.
Yeah, that's what I put in my function runtime library, Stephen. I have the same problem, right? Because see, let's say all of a sudden the package changed, right? How do I know? So I need to find out the differences. You see? I have the same problem in the function library as you have here, right? Because that's when you deal with multiple resources somehow. So you somehow need to figure out, is that a change and what do I need to do, right? And basically what I do in the function runtime library right now is the way I do it is I take all the resources that are in the cluster. So in your case, you have to query the API server, right? So in my case, it's the package. I look at my conditions. I look at what is there. Then I'm basically running as if nothing, I don't know anything. I have no history. I look at the data and then I compare and then I see, okay, I need to delete this. I need to update that, and then I just act. So that's the way the function runtime works. You see? And you need something similar here for the controller. It's very similar. Except that you only get the data from the API server, right? So you need to query Kubernetes API server to get the information.
Yeah. You have to calculate the config map and then get the config map and see whether or not it has any change. Because if it has no change, then you don't have to do anything.
Correct. But what I'm doing in my library is I'm collecting the information, right? So existing versus new, right? And then I'm comparing. And then if I see, okay, config map did not change, okay, fine, no problem, right? So then I move on. You see? But
yeah, we should kind of do the same thing.
What I'm doing is very similar to what you need.
Yeah.
It's not the same exactly because I have conditions and all that stuff. So I have a bit of other information, but conceptually it's the same.
But the good thing is config map is just string, so we can.
Yes, I do string comparison. By the way, my
string comparison is simple.
So it's like it's not very complicated.
Go is very good at that. So
yes, correct. And there is even a library that you then can do a compare diff and give you the delta and stuff like that. So there is very good libraries.
Well, I mean, for our when we actuate, it's actually much easier because it's config map update, so we have to reboot the guy anyway. So we just generate the new. If the new config map is different from the old one, we update using the new data, and then we reboot we kill the pod. That's basically what we have to do.
Correct. I mean, I can show you.
That piece of code is very generic. So, so hopefully, if Denny gets to that, it would be basically share across all three NFs.
Yeah. So you see here, right? So I have the same problem right now. So let's say I have three interfaces and someone, let's say, deletes this, right? So let's say they delete this thing, right? Now I need to act, right? So if I run my function again, right? You see my N3 has because there's another guy who's doing the delete, now gets a delete annotation true, you see? And in the cap file, the condition of N3, right, is now delete. So you have to delete the resource. You see, so I do all of that under the hood for you. Right? If I edit again and run, so this is just running the function, you will see that now my N3, so there's still a bug here, so I need to delete this annotation, right? So if it's there, and then here you see a create. So
for config map, it should be fine. Deployment updates, Actually, no, deployment, forget it. Deployment, if it changes deployment or no change to deployment, you don't care, just apply it.
Yeah.
Kubernetes will take care of it. It's okay. that one is fine. Yeah, config map data is the bad thing. So, but then that we can just compare. We can get and compare. That's fine. Yeah.
Yeah. So
cool.
Yeah, these are the things. Yeah.
So cool.
Right.
So if we have one generic NF deployment for all the types, the idea would be SMF and stuff, SMF and AMF and UPF specific logic would be factor out.
Yeah. Like all the NAD stuff.
Because
right?
the NF deployment would tell me which type it is, right?
Yeah, so you will have a type because you get SMF deployment, AMF deployment, and UPF deployment. So you get different types, right? So
I see.
And
but then they all look the same basically, which is fine.
Yeah, correct. So the only difference what you will see is that the SMF will have a peer list.
Okay.
Right. So you have to act on that probably because the others probably will not have a peer list. The other one will get DNN and I will get some other information, but that's the difference. The only difference that you see in the deployment is there will be a peer list that is filled in for SMF and not for the others. But so that means that all the code that you have is so generic, right?
Well,
the only thing that you have to do is the config map for SMF and UPF and AMF will change a little bit, right? But there are some hardcore values.
Config map will change, and then the particular things you look for in the capacity field will be different. But then
yeah, actually, capacity is one of the things which we need to also at some point to discuss because right now nothing is based on the capacity, and I just don't understand.
So I was
levels.
Yeah, I was talking to Anne about this too. So I mean, we haven't made like a full proposal how to do it, but then the vision now is because we would basically be generating different packages based on vendors, and then what platform vendor wants to run, and then what flavor of that particular network functions that it's going to run. So let's say Ericsson UPF large, if you will, the flavor of large that runs on AWS Outpost. Then you have the package that basically for that purpose, in a way. And then if that being the case, some people would have tested and qualified that this NF from this vendor for this particular large covers capacity from a range, right? From X to Y. And then so that would be using that kind of resources.
Yeah. So
they would know what kind of resources, and from that information would be basically what get propagated down to the operators, so they can fill out the CPU and memory fields of the deployment.
Well, we don't propagate CPU and memory, right? We propagate capacity.
So right now we propagate capacity. Right now we do. So the way I had it before, the vision I had before was the operators smart enough to know what it is, but then the fact is, it's not a one-dimensional thing. It's not for any platform, doesn't matter what it is. For if it's Kubernetes, I need one vCPUs and 10 gig memory for sure. That may be different when you go into like different type of nodes and different types of platforms. So that information, that resource resolutions may have to happen by encoding into a platform, into the package, because otherwise, every time you qualify something that has different resource parameters, then you have to go upgrade the operator, right?
Sure, and that's why I see, Steven, so you could write a function as a vendor that does that for you, right? So and that basically spits out a vendor-specific CR that is referenced here, and then the operator takes it, right? So you could do something like that, right?
A function in the operator, you mean?
No, a function in the during specialization. Okay. The vendor writes a specialization function that takes.
So that was our original vision, but I have to tell you, the vendors we've spoken with, they weren't interested in writing cat functions.
No, that's true. And yeah, but there is the alternative to that is to basically do it as part of the package when so you can do it at the start if they have the information, but at the moment, the way in Nefio, it's a function somehow that you can do it with the inject function that John is doing, or you can do it in the specialization, but you need to do it somewhere in that space, right? Unless you hard code it in the package from the beginning.
So that's what I'm thinking. I mean, right now, maybe we're saying that we hard coded in the package because someone who qualified it, their network function to run on a particular cloud platform for a particular capacity range would know exactly what the spec looks like, and then they'll tell you exactly this is what is needed. So one step for now.
And I agree that today vendors don't like to write these functions, but let's say we succeed in making it so simple, right? That if you show my example, it's so simple. They probably the level of, let's say, ignorance will lower going forward, right? because here's the thing, Nefio is not yet established, right? So that's why vendors are reluctant right now to jump on it. But let's say Nefio establishes itself, in which case the reluctance goes down. You see?
Yeah, so that's the goal.
But so I agree with you. So step number one is put it in the package, right? Or write it in the operator, and then going forward, there could be intermediate ways of doing it, right?
Yeah. Yep. I mean, you represent vendors, obviously, and I don't.
I can tell you what we as a vendor, how we operate. So I basically that doesn't mean my personal view is aligned, but that's how we operate, because we go for most common or let's say the biggest bang for the buck, basically, right?
Yeah, of course.
And at the moment, I think Nefio is not there yet. So my goal is to have Nefio there, in which case we will change that perception, you see?
Yeah, but so for now, the capacity was passed down for that reason. It's Danny's, as when I wrote it, but then moving forward, one would imagine it will be encoded into the package. So in which case, maybe they will be just passed to you. In another extension piece. We'll probably never put it as part of generic deployment, UPF deployment itself, but then we'll probably put it on some sort of extension things. And then
fair enough. Then for the time being, we just park it. It is like I provide generic, just hard coded values, and
it is one of the use case, right, Wim, that we like to change CPU and memory.
Yes, we want to change the capacity, but
we want to change the capacity and somehow propagate that down to
what you could do, Dennis, for the use case is to say it's large, or we could basically
we could just say large is that much, and then medium is that much, and then we can
correct. So because in my view, so do something like that, right? And we restart the whole thing, and we come up with more resources, right? So that's
okay.
I think take it as simple as that for the time being, and then say this function, this is a function that has to be specialized for the vendor going forward. We show just what is possible.
Sure. Okay. Fair enough.
Cool.
Yeah.
Okay, then I have something to do to work. Yeah, if you
I will focus on checking that in. And then I will do that.
So if you check that in. I
check that in.
I hate to use private channels, but so far this seems to be much more effective because I guess all the other channels are pretty saturated. So you can on the channels that we've been talking on this operator topic, if you can just let the other folks know also.
Yes, but I will add it to the PR, right? So I'll probably
we'll link the PR to them because
sure,
if it's generic things on the Slack, Varash and others may not even look at it. I'm not sure. So make sure that they can see it, so they can see, this is the API to follow, and then if they have other questions, they can ping us on Slack, and then I can tell them how to process this into the controller. on the
because
controller.
Steven, should I do SMF, VMF, and UPF? And this?
Yeah, just do all of them, because as you said, it's pretty much the same.
And then I refer to what I'm going to do is make a generic NF deployment, because they are all the same, right? And just refer one to the other, right? So then it's okay. Yeah. I'll do that. Yeah.
Cool. Thank you, guys.
Okay.
All right. Appreciate.
Have a good day.
Yeah.
Yes.
Bye-bye.
Well, it's actually recording, so let me stop the recording.
It's